Now we are discussing the M-way tree. M-way tree is also called the multi-way tree. Just like we are having the binary tree, similarly we are having the M-way tree. So we can say that M-way tree is the generalized version of the binary tree. We know that the binary tree is a tree which contains two children. But here talking about M way, here we are having the multiple childs. So it can be 2 child, 3 child, 4 child or up to M child. So that means M way tree is a tree which can have more than the 2 children. Well, one thing is important. It can have more than 2 children. Well, that doesn't mean Amway tree is not having the 2 children. Amway tree can have 2 children, 3 children, 4 children. But if you compare the Amway tree with the binary tree is strictly having the maximum 2 children. Means if we talk about the binary tree, it can have 0 children, 1 children or 2 children. 2 is the maximum limit. But talking about the Amway tree in the same manner as the binary tree, but it can has multiple children, 2, 3, 4, 5. So any children it can have. So that's why the name given is the Amway, because it can be having the multiple childrens. So it can have the more than 2 children also. Now, if we talk about the Amway tree, it is of order M, where the M is the meaning that each node has maximum M child. Now, to understand this, let us take some examples. Let us suppose that we are having a three-way tree. So, if we talk about the three-way tree, then obviously three-way we say it as it is of order 3. And how many children are there? So, maximum children can be 3. Now we are taking one more example. Let us suppose we are having the five-way tree. So as the name five-way, that means it is of order 5. That means maximum 5 children can be there. There is one more thing in the M-way tree, which is the keys. Just like the each node is having M children, similarly each node can have maximum M1 minus 1 keys. So now if we talk about the first example which we have taken, where we are having the three-way tree, where we are having the maximum 3 child. So there m minus 1, that means 3 minus 1. So here if we take the value of m is 3, that means 3 children can be there, and m minus 1, which is equal to 3 minus 1, and that is equal to 2. So that means 2 key fields will be there. Similarly, if we take the example of five-way tree, there we are having the value of m is 5, that means it is five-way tree, and there we are having the 5 child. And how many key fields are there? We know that key fields are m minus 1, and the value of m is 5, so 5 minus 1, which is equal to 4. So this is the 4 key fields. Now, first of all, we are understanding that what is this key fields and what are these children with the help of the real life example and the diagram. So here we are having a diagram. In this diagram, we are having so many blocks. So let us suppose that I am going to assign certain numbers here, or maybe some of the values. Let us suppose that I am giving a value like this, the value is 9 and this is 20. Now these two values which I have stored into the blocks, now these two are called the key fields. So that means if I talk about one of the node, now these are the 2 key fields. You can see that this is the one key field, this is the another key field. So here this is the 2 key fields are available. Now afterward, in every key field, there we are having some further blocks. So you can see that there are 3 blocks available, 1, 2 and 3. So these 3 blocks are nothing but they are representing the children. So these are the children of this specific M-way tree. Now you understand one thing. How many children are there? It is 1, 2 and 3. That means if I say child are 3, and I can say that M m is equal to 3, because you understand one thing. Here we have learned the number of m's are there, that is number of child. So here we are having 3 child, means we are having the value of m is 3. If the value of m is 3, that signify the number of child will be 3. So I can say that this is nothing but the three-way tree. So this is m-way tree and the value of m is 3, that is the three-way tree. And how many key fields are there? We know that if I talk about the child, then child is equal to m and is equal to 3, because it is a three-way tree. And if we talk about the key fields, then key fields are nothing but that is equal to m minus 1. So if I talk about m minus 1, that is equal to 3 minus 1, and that is equal to 2. So now you see how many key fields are there. These are 2. So 1 and 2. 2 key fields are there. That means this complete thing we are representing, this is nothing but a node. So here the first part which we have discussed, that is nothing but a node. Now remember one thing. Here we are learning a three-way tree where the value of m is 3, means children are 3 and key fields are 2. Now it is the maximum limit. If we are having a three-way tree, then maximum 3 child can be there. It can be 2 child or 1 child or can be 0 child also. So this is the maximum limit of the child. Similarly, talking about the key field, here we are having 2. That means maximum 2 key fields can be there. It can be 1 or it can be 0 also. So that depends. The cases we will discuss. So but one node we have discussed. In the one node we are having 2 key fields, which is 9 and 20, and they are having 3 child fields. They are available. So that is the one node. Now understand one thing. If we are discussing this three-way tree, then obviously every node should be following the property that there should be maximum 3 child and maximum key value should be 2, which is 3 minus 1, that is 2. So here you can see that we are observing, so this is another node. Let us suppose that we are taking this node and we are assigning some of the values here. Let us suppose we are giving certain values. The values can be like it is 3 or 7. Now we know that these values are nothing but these are the key fields. So we can say that these are the key fields of this particular node. Now further we are having the 3 blocks and these 3 blocks represent the children. So there the children will be whatever the keys plus 1. Obviously there are the 3 children. Now here you can see that there is no further node connected. Now we are representing it as cross. Cross means it is having no children. So whenever an empty block is there and there is nothing and we will put the cross, that cross means there is no children. Now we are going towards the next node. So this is the next node that we are taking, and here we are going to take out the key fields. Let us suppose the key fields are 10 and 17. Now these are the key fields. Then afterward we are having the 3 blocks of the children. We will represent the cross here because there is no further pointer connected. So cross means there is no further children available. Now we are taking the another node of the three-way tree. Here if we talk about the key fields, then maybe the key fields can be 21, 30. So these are the 2 key fields. Now further we are taking the children, but there is no pointer available. That's why we are representing the cross. Cross represent the null. We know that null pointer, just like we have gone through the linked list as well. In the linked list there is a null pointer. Null pointer means whenever there is nothing forward, we say it as null. So these cross represent the null. That means whenever we are placing the cross, now this cross that represent nothing but the null pointer, and null pointer says that we are not having anything further. So that is the null pointer. So this cross we are representing for the null. There is one more thing that we has to learn. We can see that there are three links which are available. This is 1, this is 2, and this is 3. So these are the three links available. These are nothing but the pointers to the subtree. So now we have learned everything. We know that first of all, whenever a MV tree is given, we should find out that what is that MV tree. So if MV tree is given, we should find out that what is the M. So there 3 ways given. That means the value of M is 3. That means every node will be having maximum 3 children. So here if we are talking about the first node, there the 3 children are there. 3 blocks are mentioned. Now in these 3 blocks they are representing the children, and afterward the number of children are there. That -1 is the key field. So 3 children are representing here. That means 3 minus 1 is 2. 2 key fields are present. So this is representing a node. Now afterward we have learned that there are the pointers which are going. So these pointers are nothing but the pointers to subtree. So every node which are further are the subtrees, and they also are having the key fields as well as the different children. And whenever we are having a cross, dash cross means the null pointer. So that is how we can represent the MV tree. Now we are taking some examples to make you understand more about the MV tree. The first example I am taking of the two-way tree. So now we are learning the two-way tree. Whenever a two-way tree is given to us, first of all we should understand that it is a M-way tree. Now talking about the value of M, that is equal to 2 here. That means this tree is of order 2. So that means how many maximum children can be there? Now we know that maximum children in any of the tree will be is equal to order of M. So maximum child here will be equal to M. And what is that? That is equal to 2. So in the mind we can construct a block where we are having the 2 child. So let us suppose that we are defining a block here. Now this block is having the 2 child. So these 2 child is of 2 children we are having. So that block represents the 2 children. Now further we have to find out the key field. We know that the key field, there is a formula given to us. So key field is equal to M minus 1. So here M minus 1 is equal to, that is 2 minus 1, and it will be equal to 1. So maximum 1 key field will be there. Now above the children we should connect 1 key field. So you can see that 2 children are there. 2 minus 1, that is 1. So that is representing the key field. So this is how we can generate the node of a two-way tree. This is the maximum limit. So this is the node which is ready. So now we can say that this complete is nothing but the node. So here we have successfully generated the node of the two-way tree. Now we can define the different two trees which are possible. Now first of all we are generating a two-way tree. Let us suppose that this is the children. That means the maximum limit is 2. Above that we are having the key field which is 1. So let us suppose that we are having the case 1 where we are having a single element. Let us suppose that in the key field we are having only 7. Now if we are having only one node available and there is no children, so in the children boxes we are putting the cross. So one node, that means a 7. So there is only one node available which is 7, which is having the no children. So this is the case number 1 of two-way tree. Now I'm taking one more case where we are having a two-way tree with only one children. So we know the criteria, that means maximum 2 children can be there. So we have created the 2 boxes for the children. And maximum 1 key field can be there. So 1 key field I have created. Let us suppose that this is the key field which is having the value, let us suppose 7. Now there on the left hand side we are having 1 children. So that means 1 children means there will be 2 further children that can be possible. So I have taken the 2 children further. because that is only the one children, so there we are having the one key field available. Let us suppose the value we have taken, that is 5. So now here on the left hand side, that means on the 7, on the left children, we have connected the node which is 5, which is having the further 2 children which is blank. So here we can see that if we talk about node 7, in the node 7 there is one key field and there is the possibility of 2 children. Out of that, one is the pointer and one is the null. So that means on the left we are having one children, on the right we are having null. Talking about the node 5, here we are having the cross and cross, that means null and null. So this is the category where we are having a node which is only having the left children. Now I am taking one more example. Let us suppose that there is a node which contains 2 children. So first of all, we know that the criteria that in the two-way tree there can be maximum 2 children. So 2 blocks I have created for 2 children. Now m minus 1, so 2 minus 1, that means one key is possible. So this is one node. Let us suppose that the same value I am taking, which is 7 here. So this is the one node created, which is one key and 2 children. Now it has the left child. So here also I am creating the 2 boxes representing the 2 children and one key field, which is 2 minus 1. So it is one key field. Let us suppose that here we are having the 5. So here on the 7 we are having one left child, which is 5. Now after the 5 there are 2 cross, that means after 5 there is no further children available. Now we are going to construct the right child of 7. Similarly, we know that we are learning the two-way tree, so maximum 2 child possible, that's why 2 blocks are created. Above that, 2 minus 1, so one key field is created. Let us suppose that this value we are taking is 10. So here on the 7 right hand side we have created one node which is having one key field 10 and 2 children, which is cross. Cross means null. So here we have discussed the two-way tree where we are having the single node, we are having the one left child, we are having the 2 child. So here we have discussed the 3 cases of two-way tree, which is no child, one child and the 2 child. You can see that this two-way tree is very much similar to the binary tree. That's why the binary tree is the sub part of the two-way tree. Because m-way tree, you know that it can be 2-way, 3-way, 4-way, 5-way or n-way. Means multiple ways can be there. That's why the binary tree, which is only the two-way tree, so we can say that binary tree is the sub part of m-way tree. That's why in the definition it is said that m-way tree is the generalized version of binary tree. Now we are going to discuss the three-way tree to understand more about the m-way tree with the different conditions. So now we are learning the three-way tree. So now we are learning the three-way tree. In the three-way tree, first of all, we should understand that it is the part of m-way tree. So we should find the value of m. Well, the value of m is 3 because it is a three-way tree. So it is having the order of 3. Order of 3 means how many maximum child it can take. It can take the maximum child 3. So maximum child is equal to m and that is equal to 3. Now we are going to find out the maximum key fields. Maximum key fields is equal to m minus 1. So key fields m minus 1 is equal to 3 minus 1 and that is equal to 2. So means every node in the three-way tree will be having maximum number of child, that is 3, and maximum key fields, that is 2. So now we are going to construct a node for the three-way tree. The node which we are constructing is having the maximum child here. We can see that the maximum number of child present are 3. So here we are constructing a node which is having the 3 child. So let us suppose that there are 3 blocks. 3 blocks are representing the 3 child. Now maximum key fields. So here 3 children are there, so that will be 2. So above that we are representing the 2 key fields. So this is the 2 key fields and 3 children. So we can say that this is the maximum possible node which is present here. So this is the node of the three-way tree. Now this is the maximum possibility. What I am saying, I will tell you, because maximum 3 children. So here we should take the cases where 2 children can be there or no children can be there. So first of all, we are taking a case where we are having a three-way tree. Let us suppose that we are having the first node which is having the 3 children. So how to make that? Now 3 children means 3 boxes we have taken. Now how many key fields can be there? 3 children are there, that means 3 minus 1, that will be 2. So 2 key fields we are taking here. I am taking different colors to make you understand about the differentiate between the key field and the children. Otherwise there is no need to take out the different color. Let us suppose that the key field are containing some values, like it is having the 7, it is having the 20. So these two values are taken. Now if I has to put a left child here, now left child, I am assuming that there is only a single key field. Then how can we construct? Single key field means it will be having 2 children. So here on the left hand side I am constructing a node which is having the 2 further children. So first of all 2 children I am creating. So that means 2 blocks are there. So now 2 children are there, that means 2 minus 1, that means 1 key field is there. In the key field I am, let us suppose, putting 5. Now this thing is very interesting. Three-way tree may have 3 children and as well as 2 children. So that is thing which I want to represent here, because in the 3 field we have said maximum child are 3. So that means here the node which we have created is having the 2 child. So now this node I am just attaching. So here the 1 child of 7 and 20 we have attached is 5. Now we are assuming that there we are not having any further child, so we are putting the cross here. So cross means null. There is no further child available. Now we are assuming that in 7 and 20 there is no child. So here I am putting the cross, that means no further child available. I am taking one more case here. In means let us suppose in 7 and 20 we are having one more child which is having the 3 children. So let us suppose here the 3 children, that means 3 blocks. So here we can connect the 3 blocks here, that means 3 children. 3 children, that means 3 minus 1, so there will be 2 key fields. So here 2 key fields are available. Let us suppose their value which I am putting is 21 and 70. So any random values I have taken. So this is the node which is attached with the 7 and 20 children. Now this is the MV tree which we have created. Let us suppose that there is one more node which I want to connect, but before that I am putting these two cross. These two cross means these two child are not available. So here we are taking one more node here. Let us suppose that it is having the 2 child. So that means 2 blocks will be there for the 2 child. Now 2 child are there, that means 2 minus 1. So here 1 key field will be there. Let us suppose that the value which we are taking is 75. So there we have taken. Now this node is connected at the right hand side of 21 and 70, and afterward we are having the null values. So null means there is no further child. So now first thing we should understand that if we are learning any of the tree, let us suppose the three-way tree, it can have the maximum child, that is 3. Maximum child 3 means it can be 3 child, it can be 2 child, 1 child or 0 child. Do not make this in your mind that it will always be having the 3 child. No. 3 is the maximum. So here it can have 3, 2, 1 and 0 child. Now you can see if we talk about the first node. Now here this is the first node if we talk about. Now here we are having the provision of 3 child. So 1, 2 and 3. So provision of 3 child is there. That means key fields are taken afterward, which is 2. So 2 key fields are available. But here we have taken only 2 child. So here this node can contain the 2 child because 1 child is null and 2 childs we have taken, and these 2 childs are the further pointer. Similarly, if we talk about the next node, which is on the left hand side, here we are having the provision of 2 child. So first you create the child provision, then afterward take the keys. Now we know that the maximum keys depend upon m minus 1. So here you know that the child provision was 3, so maximum keys provision was 2. Here in this node, the 2 child provision is there, that means key is only 1. So 2 minus 1. But here we have not connected any of the child because child is not present, so no child in this node. Now if we talk about the next node, here we are also having the provision of 3 child, 1, 2 and 3. So 3 provision of the child, that means 3 minus 1, 2. So 2 key fields we have attached. Although we have not taken the 2 child because no childs are present, and we have connected one pointer which is going to the next node. In this node also we are having the provision of 2 child. So 1 and 2 and 2 minus 1, that is 1 key field is attached, although we have not taken these 2 children. So we should understand one thing, 3-way tree, that means maximum 3 child. It can be having 3, 2, 1 and 0. Similarly, if we talk about 5-way tree, maximum 5 child, it can be having 5, 4, 3, 2, 1, 0. Similarly, 50-way tree, it will be having the 50 child maximum. And if you talk about the keys, keys will always be 1 less than the child you create. If you are creating the 5 child, take the key 5 minus 1 as 4. If you are creating the 50 child, then 50 minus 1, 49. So that will be the key fields. So this is how the M-way tree work. So we have discussed here different ways trees and their different representation so that we can learn the M-way tree. So this is all about the M-way tree.